Good evening. This is video number 400. In this video, I'm going to explain the difference between part correlation and partial correlation in SPSS regression output. So first, I would like to define both of these types of correlations, that is part correlation and partial correlation, and then I'll give you some example, and finally I'll perform the comparison of partial and part correlation using regression output, and I'll show what is the meaning of part correlation in regression. A part correlation is also known as a semi-partial correlation, which is the correlation between an independent variable and the dependent variable after the linear effects of the other independent variables have been removed from the independent variable only. On the other hand, a partial correlation is the correlation between an independent variable and the dependent variable after the linear effects of the other variables have been removed from both the independent and the dependent variables. So, in case of part correlation or semi-partial correlation, we remove the linear effects of the covariates or confounding factors from the independent variable only. Whereas in case of partial correlation, we remove the linear effects of the other variables from both the independent and the dependent variables. Here again, this is a partial correlation definition. I'll give you an example. Let us suppose a researcher studying occupational stress may be interested in the correlation between the length of time a person has worked with a company and their level of stress while controlling for one or more potentially confounding variables that may include age and salary. In a partial correlation, the influence of the control variables on both the independent variables and dependent variables are taken into account, that is, they are removed. In our example, this would mean that the partial correlation between time with the company and stress would take into account the impact of age and salary on both time with company and stress. The part correlation, as I mentioned earlier, is also referred to as the semi-partial correlation. Like partial correlation, the part correlation is the correlation between two variables, that is independent and dependent, after controlling for one or more other variables. However, for the part correlation, only the influence of the control variables on the independent variable is taken into account. So it means here we control for the effects of other variables on the independent variable. In other words, the part correlation does not control for the influence of the confounding variables on the dependent variable. In terms of our earlier example, this would mean that the part correlation between time with the company and stress would only take into account the impact of age and salary on time with the company rather than the stress. We may wonder, why would we only want to control for effects on the independent variable and not the dependent variable? The primary reason for conducting the part correlation would be to see how much unique variance the independent variable explains in relation to the total variance in the dependent variable, rather than just the variance unaccounted for by controlled variables. Let me simplify it further. One of the problems that arises in multiple regression is that of defining the contribution of each independent variable to multiple correlation. One answer is provided by the semi-partial correlation SR. SR stands for semi-partial correlation, and its square, SR square. In SPSS, this is referred to as the part correlation. Partial correlations and the partial correlation squared are also sometimes used. So it means either we use semi-partial correlation SR and its square, or we may use partial correlation and the partial correlation squared. But usually we will use semi-partial correlation and it's squared. So semi-partial correlations indicate the unique contribution of an independent variable. Specifically, the squared semi-partial correlation for a variable tells us how much r square will decrease if that variable is removed from the regression equation. And so how to compute part and partial correlation in SPSS? For that purpose, I'll open my SPSS file and I'll show and then explain. This is my data file. There are a number of variables. This is gender, this is race, this is school type, this is program, this is reading score, this is writing score, this is math score, this is science score, and this is social study score. And this is the variable view. So I'll do that in regression. So I'll go to linear regression and let me take this out and let me take all these variables from here. So let us suppose this is my dependent variable, that the reading score depends upon these variables. Let me scoot them here in this independent list, and I'll click on statistics, and in click on statistics I would like to click on this model fit. It will give me model fit, it will give me the coefficient estimates, and it will also give me part and partial correlation. So I need to check these three boxes. After that, let me go to OK, and here is this is the enter method that I use for this regression, and this is my model summary. This is the correlation coefficient between the actual and the observed dependent variable, and this is r squared, that is the coefficient of determination, and this is the adjusted r square. Below, this is the ANOVA, and this is the f state, and this is p value, and this p value shows that the overall equation is significant. Here in this table, these are my independent variables: writing score, math score, science score, and social study score. These are unstandardized coefficients, these are standardized coefficients, these are the t values, these are the p values, these are the bivariate or zero order correlations, and these are the two correlations. One is partial correlation and one is a part correlation. Since this topic is on the difference between partial correlation and part correlation, remember, part correlation is also known as semi-partial correlation coefficient. So in order to explain this, the coefficient of determination, or the r squared, for this model is 0.589. This is for the whole model. Now the part correlation coefficient regarding the writing score is 0.071. So if I take the square of this value, then this would mean that if I remove the writing score, then the r square will decrease by the square of this value. Similarly, if I remove math score, then the square of this value, that is 0.192, this will decrease r square by this amount, that is 0.192 multiplied by 0.192. Similarly, if I remove science score, then this r squared value will decrease by the square of this value, 0.195 multiplied by 0.195. Similarly, if I remove social studies score from this model, then the r squared, which is equal to 0.589, will be reduced by the square of 0.219. So basically this means that the square of the part correlation, or the square of semi-partial correlation, basically shows us by how much the r squared will reduce if we remove that particular variable. So this is the explanation of part correlation, and the partial correlation coefficient basically means that that if we remove or if you control for other variables, then this shows the coefficient of correlation between the dependent variable and that particular variable. For example, for math score, partial correlation is 0.286. So this would mean that if we control for writing score, science score, and social studies score, then the coefficient of correlation between the dependent variable, that is the reading score, and the math score is equal to 0.286. And if we don't control for the other three variables, then the coefficient of correlation between the dependent variable and the math score will be 0.662. So this is a brief explanation and difference between partial correlation and semi-partial correlation, or partial correlation and part correlation. So this is how we compute partial and part correlation, and this is the interpretation of zero order correlation, partial correlation, and semi-partial correlation or part correlation. Ladies and gentlemen, if you have not subscribed to this channel, kindly subscribe to the channel, and do not forget to click on the bell icon so that you could get notification about my other videos that will be uploaded for you. Thanks for watching. I would like you to share this video with your friends, with your colleagues, and with your students, so that they can also get benefit of this video lecture. Thank you, and see you in another video.